Classes and methods. Same ideas, different terms. All object-oriented programming languages have the following concept, although the terms they use may differ. Classes, object type, factory object. Instances and objects. Message passing, method lookup, member function invocation, method binding. Methods, member function and method function. Inheritance and subclassing. This chapter will describe the definition or creation of classes and illustrate the mechanics of declaring a class and defining methods associated with instances of the class. Encapsulation. Encapsulation and instantiation. Classes provide a number of very important capabilities. Encapsulation. It is a process of binding the code and data together into a single unit. A service view, the ability to characterize an object by the service it provides without knowing how it performs its task. Instantiation, the ability to create an instance of a class. For example, how do you think a car runs? Is there only steering, brake and whatever you are able to see directly? No, there are many parts inside the car to make it run, like engine, wires, tank, etc., which we don't see. Thus, we can say that car is basically a collective unit of many parts which help it to run. Same way, in classes, we have functions and data members wrapped up or encapsulated together. Internal and external views. Encapsulation is used to refer the two views of the same system. Outside or service view describes what an object does. The inside or implementation view describes how it does it. For example, the user would see only the description of the legal operations, say push, pop and top, in an abstraction of a stack data type. On the other hand, the implementer needs to know the actual concrete data structures used to implement the abstraction, as shown in the above figure. The concrete details are encapsulated within a more abstract framework. Behavior and state. A class can be viewed as a combination of behavior and state. Behavior. It means that action or work performed by an object. For example, student attend a course, computer science. State. The state is defined by the attributes of an object. For example, student have first name, last name and age, etc. Class definitions. We will use as a running example the class definition for playing card abstraction and show how this appears in several languages. Class definition in C++. Class person, open bracket, public, that is access specifier, string name, integer, age, bracket close, semicolon. A class definition is terminated by a semicolon in C++. Visibility modifiers, that is public, means all the class members declared under public will be available to everyone. By placing the definition inside the class in C++, the programmer makes clear the link between two data types. A C# class definition. Using system, semicolon, namespace, person name, open bracket, class person, open bracket, public, private string name, public integer age, bracket close. C# class definitions have minor differences, no semicolon at the end, and visibility modifiers are applied to methods and data fields individually. Java class definition. Public class my first Java program, bracket open, public static void main string arguments, array, open bracket, system.out.println hello world, bracket closed. To compile the source code, use the following command: javac space my first Java program dot java. To execute the program, use the following command: java space my first Java program. You'll get the output hello world. Java also applies visibility modifiers to each item individually. It does not have enumerated data types. Instead, it uses symbolic constants. Visibility modifiers. The internal and external aspects of a class are differentiated by the terms public and private. Public, it means all the class members declared under public will be available to everyone. They are the external view. Private features can be modified only within a class. They are the internal view, that is implementation view. Typically, methods are public and data fields are private, but either can be placed in either category. Static and final. Static means that all instances share the same copy of the variable, one per class. Similar meaning in many languages. Final. If you make any variable as final, you cannot change the value of final variable. It will be constant. C++ has const keyword that is similar although not exactly the same. Public static final integer count equal to 10. Public static final float pi equal to 3.14. Public static final integer max underscore price equal to 999. Public static final integer minimum underscore price equal to 699. Methods. A method or message in object-oriented programming is a procedure associated with an object class. An object is made up of behavior and data. Data is represented as properties of the object and behavior as methods. Although syntax will differ depending upon language, all methods have the following. A name that will be matched to a message to determine when the method should be executed. A signature, which is a combination of return type and argument types. Method with the same name can be distinguished by different signatures. A body, which is the code that will be executed when the method is invoked in response to a message. An example from C#. Using system, namespace, car program, open bracket, class program, open bracket, static, void main, string arguments, open bracket, car space car. Car equal to new car of red. Console.writeLine of car.describe. Car equal to new car of green. Console.writeLine car.describe. Console.readLine bracket close. Next program, class car, open bracket, private string color, public car of string color, open bracket, this dot color equal to color, bracket closed. Public string describe, open bracket, return this car is color, close bracket. Public string color, open bracket, get return color, set color equal to value, close bracket. The above given program explains about the functions of method in C#. We have created a new class called car and the attribute color is declared as private. Then we have declared the constructor and method describe to print the value of the color. Then another class program created with the main function. We have created the object for the car and through that object the describe method can be called to print the appropriate color which is assigned. Constructor public car string color open bracket this dot color equal to color bracket close. A constructor is special method of a class which will invoke automatically whenever instance or object of class is created. In C++, Java and C# and many other languages, it has the same name as the class. The above program shows that the car constructor which is automatically invoked to assign the current value of an object to the color attribute. Accessor or getter methods. An accessor or getter is a method that simply returns an internal data value. Public string get color open bracket return color close bracket. Here is a simple program which returns the color value as string format. Why to use an accessor? There are many reasons why an accessor is preferable to provide direct access to a data field. The method can be declared as public. It is used to return the value of a private field. It makes it easier to change the access behavior. For example, count the number of access. Some conventions encourage the use of a name that begins with get, that is, as in getRank, but this is not universally followed. Setters or mutators. A setter, sometimes called a mutator method, is a method that is used to change the property of an object, that is, change or modify the value of the variable. Public void set color of string color. This dot color equal to color, bracket closed. This program shows that the method setColor is defined to assign the current value of the color. Mutators are less common than accessors. but the reasons for using them are similar to accessors. Constant or immutable data fields. Some languages allow data fields to be declared as constant and it cannot be modified. That is, const modifier in C++, final in Java. Other languages have other conventions. Constant data fields can be declared as public since they cannot be changed. For example, public const float pi equal to 3.14. Order of methods. For the most part, languages don't care about the order that methods are declared. Here are some guidelines. List the important topics first. Constructors are generally very important. List them first. Put public features before private ones. Break long list into groups. List item in alphabetical order to make it easy to search. Remember that the class definitions will often be read by people other than the original programmer. Remember the reader and make it easy for them. Separation of definition and implementation. In some languages, such as C++ or Object Pascal, the definition of a method can be separated from its implementation. They may even be in a different file. Class add open bracket void add one of integer x comma integer y open bracket integer c equal to x plus y system.out.println the result is c bracket closed. Class main open bracket public static void main string arguments open bracket add a equal to new add a dot add one of 2 comma 3 bracket close. In the above given program, we have created two classes. One is add and another one is main. In the add class, we have declared the method add1 which accepts two parameters and performs the addition of two values, that is x and y, and print the result which is stored in the variable c. Consideration in method definitions. Before defining the method, we need to consider few points. Have to summarize the purpose of the method. The naming conventions should be followed for assigning the names for the methods. We have to decide what type of parameters and return types are used. Interfaces in Java. An interface is like a class, but it has no implementation. Later, another class can declare that it supports the interface and it must provide an implementation. Interface pet open bracket public void test close bracket class dog implements pet open bracket public void test of open bracket system.out.println interface method implemented bracket closed. Then public static void main string arguments of open bracket pet p equal to new dog of p dot test close bracket. In the above given program, we have declared the interface pet and method test is declared inside the interface. The definition for test method is defined in the class dog, that is main class. We have created an object for the class pet and using pet class object we are calling the method test which is implemented inside the dog class. This test method prints output as interface method implemented. Properties. Properties are a way to define getters and setters but allow them to be used as if they were simple assignments and expression. The below given method pointX declared the variable x as 0 and returned the value of x. Public integer pointX of open bracket integer x equal to 0 return x bracket closed. Inner or nested classes. The Java programming language allows you to define a class within another class is called nested class and the class that holds the inner class is called outer class. The below given program shows the class Java underscore inner underscore class which is declared inside the class Java underscore outer underscore class. Class Java underscore outer underscore class open bracket class Java underscore inner underscore class open bracket and then bracket closed. Class data fields. A Java field is a variable inside a class. All the instances of a class can share a common data field. A variety of mechanisms are used by different languages to implement this concept. For example, suppose we wanted to keep track of how many instances of a class have been created. The below given program can be used to print the number of instances for a class. Initially, we have declared the variable count as 0. Then we are declaring the method number underscore objects of to increment the count variable. Whenever the objects are created using new operator, then the count variable is incremented. Public class number underscore objects open bracket static integer count equal to 0 number underscore objects of open bracket count plus plus bracket closed. Public static void main string arguments of open bracket number underscore objects object 1 equal to new number underscore objects of number underscore objects obj 2 equal to new number underscore objects of number underscore objects obj 3 equal to new number underscore objects of system.out.println number of objects created plus count bracket closed. Real world examples. Class. Let's say that you are going to buy a car. The showroom manager asks you some details like color, model, engine type, dashboard and seat color. We can understand about class and objects from the above situation. The car is the class here and you are actually getting an object of the class. It may be whatever brand with the inputs you provided to the showroom manager. So whenever we need to create an object that is buying a car, we need to give some details that is mandatory input, that is the attribute of the class. Constructor. Now you have provided the inputs needed for the car. These inputs will be processed by the manufacturing plant, that is constructor, and return you with the car, that is object. So whenever you create an object, a function called constructor is called to create that object. Summary. In this chapter, we have examined the static or compile time features of classes, the syntax used for class definition, the meaning of visibility modifiers, that is public and private, the syntax used for method definition, accessor or getter methods and mutator or setter methods, variations on class themes, that is interfaces, properties, nested classes and class data